My name is Julio Autino. I'm the Dean of the McCormick School of Engineering and Applied Science. I welcome all of you to our winter PhD Houdin and Master's Degree Recognition Ceremony. And a special welcome to those who are joining us from locations around the world through our webcast. It is a pleasure to have you here today. You have worked hard to reach this point, and it is fitting to mark that end with an appropriate ceremony. Both our PhDs and master's students play a critical role in McCormick. As graduate students, you not only challenge yourself to learn new things and create new knowledge, but you also served as role models and mentors for other graduate students and our undergraduate students. You connected with colleagues across departments and schools, and you enrich many of our programs by bringing your unique perspectives. I recognize that some of you have made special sacrifices, either by putting your careers on hold while pursuing your full-time degree, or by combining substantial part-time study with full-time careers. It has been an honor for us to participate in your education. Our school is a better place because you are here. Today should be an incredibly proud moment for all of you, but you could not achieve or have achieved this without the help of your parents, spouses, family, and friends who have shared in the many sacrifices, challenges, and successes of graduate study. Let's give all of them a round of applause. So graduates, over the course of your education, you have learned not only deep technical skills, but also timeless skills that resist obsolescence. Maybe it is to learn how to think in terms of systems and interrelations, or how to make sense of data, or maybe it's in design thinking skills that help you how to frame problems. Whether you are starting new careers or moving up in current ones, whether you will go into positions in academia or industry or anywhere in the corporate world, you now hold the advantage of knowing how to frame problems, how to solve the right problem behind the perceived problem, and also that finding the right question is sometimes more important than jumping in to find an answer. You will take these skills wherever you go. One of the best things of our PhD and master's programs is that our students represent a broad range of ages, backgrounds, and careers. You all have brought a diversity of thought and experience to your education, and you will live not only with a degree, but with a community of some of the best minds in the world. I want to thank you, our graduates, for having put your faith in us and selecting McCormick to pursue your graduate studies. Our faculty members are proud of your accomplishments, and we wish you the greatest of success in your future careers. Congratulations to all of you. Now I have the great pleasure of introducing our convocation speaker. Very few alumni have the diverse experience and skills that could relate to the wide variety of programs that are represented here today. As one of the most connected people in Chicago business, and I'm speaking not metaphorically in this case, you can back it up, Google it if you want, I knew that Chookaszian will be an ideal, fantastic choice. Dennis served as the chairman and CEO of CNA Insurance Company from 1982 until 1999. He previously served as president and CEO of the company. And from 1999 until 2001, he was the CEO of Empower Incorporated and has also served as chair of the Financial Accounting Standards and Advisory Council. Throughout his career, he has served, and this is an amazing number, he has served as director on the boards of 12 publicly traded companies and 50 private corporations. He received his bachelor's degree in chemical engineering from Northwestern University, a master's degree in business administration from the University of Chicago, and a master's of science degree in economics from the London School of Economics. It is my distinct pleasure to welcome Dennis Chookaszian.
Thank you very much, Julio, and it's a pleasure to be here. My degree from Northwestern was in 1965, 50 years ago, and things have changed a bit since that time. And I'd like to just try to put a little bit of that in perspective. When I was here, the primary thing that I had to do was learn the Clausius-Clapeyron equation and understand the principles of chemical engineering. And the society was a relatively stable society at that point, not that much change, although at the time people thought there was a lot of unrest, but in fact, relative to today, it's quite different. And so things have evolved dramatically, and I'd like to focus this morning in our brief time here on what are the changes that have occurred. And I think the two dominant changes that are really very different today from 50 years ago when I was here are, one is communication. With the advent of social media, all the various forms of communication, we communicate much more rapidly, information changes, and it changes all societal processes. Elections are now driven by communications in ways that never happened before. That's one factor. The other factor that's less talked about, but I think a very important one, is the changing nature of ethics in the society. And I'd like to take and just give you one little example of that, of the impact that ethics has on what we make as decisions. And that, the changing nature can be looked at when we look at autonomous vehicles. When you look at autonomous vehicles, the self-driving cars, and I'm sure you've followed a lot of what's going on there in some of the debate, but it's interesting how it's changed the nature of the actions that you have to take with regard to those vehicles and what happens with regard to the decisions that will be made by a computer that were made by you as an individual. I'm going to start with a story that goes back quite a while ago, about 30 years ago, and it talks about the setting of governance principles within corporations. Ford Motor made a car called the Pinto. The Pinto had a defect, which was when hit from behind, the gas tank was so close to the rear bumper that it exploded and caught fire, and obviously causing huge damage to the passenger's death was a very serious consequence, obviously, of what happened when you had those explosions from the gas tanks. So it happened, and when that event occurred, there were a number of crashes like that. Lawsuits were brought. In the trial, what came out was that the Ford engineers had actually seen the videos of the car being hit from behind and exploding, and they were going, holy cow, look at this, what do we do now? And they looked at it, and they did an evaluation of what it would take to correct the difference. And the difference was a pretty small difference, and this is all online, by the way, you can read about this if you're interested. It was about $14 or $15 per vehicle, but across all the vehicles, $130 million. And so they looked at it, and they did a calculation of how many people would die every year. And it turned out to be that it was around 8 people a year they estimated would die a year by this. They calculated the cost of a settlement at $1 to $2 million per death, so they contrasted 130 million versus 10 or 15 million and said, we're not going to make the change. They didn't make the change. The jury saw this, was incensed, and they awarded $130 million to this one individual. And so that set a standard that fundamentally communicated through the courts to all corporations that there is no value you can place on human life. You have to do your utmost to protect it regardless of the cost. So fast forward to today with automation, and so what does that have to do with today's vehicles? Well, that principle still exists. In automobile manufacturers, they do everything they can to make that the safest possible vehicle regardless of cost. So I'll give you a couple of examples. You're driving on a road, 2-lane road, semi coming at you this way, you're going in the other direction, going 65 miles an hour. The semi pulls into your lane. Oh, okay. Thank you. The semi-truck pulls into your lane, and you realize that when you're driving that you have two choices. There's another semi behind. You can't go left, so the only choice is to slam into the truck or go right. If you go right, what you're going to do is jump up on the sidewalk, and there's a pedestrian, a woman pushing a baby carriage with a baby in it. So you realize those are your two choices. What are you going to do? The instantaneous reaction that almost everyone has is self-preservation. You jump up on the road and you hit the pedestrian. I teach a course in corporate governance, and when I ask students, what do you think you would do, 95% of the people say, I realize that my reaction is going to probably be to make that ethical decision to jump up on the road and hit that pedestrian. So now you're in the same situation, but you're now in an autonomous vehicle. The car's driving down the road in the same way. It comes to that same circumstance, and now you're in the back seat, and so what does the car do? Does it slam into the truck, or does it jump off, break the traffic laws, and hit the pedestrian? Remember the Ford Motor case, can't jump off the road. If it jumps off the road, that's the exact principle that that was established with the Ford case, that you can't jump off the road and kill the pedestrian, breaking traffic laws. So you have to slam into the semi. Would you buy that car? You're not going to buy a car that's going to kill you, because that's going to make a decision you wouldn't make. So what are the choices? And I'll give you three options. First option is the manufacturer, when they're making that decision, of course, has to decide whether to jump off the road or not. They almost can't make that decision. So a second option would be that when you get into the car, two buttons pop up. The one button says, protect the pedestrian. The other says, protect the passengers. You push a button. You make the choice in advance, and you've now solved the ethical dilemma, and you've made your ethical choice. I'm your auto insurer. I'm not going to insure you if you pick slam into the truck, because that's going to be a much more expensive case. So if you can't do either of those two, what's the choice? The manufacturer can't do it. You can't make the choice, so how does that choice get made? Can't be random, so there has to be a way to do it. So I'll give you an engineering idea that one of you may want to take and develop into a Nobel Prize winning solution. So when this occurs, each of the individuals within the society, man, woman, and child, is going to be required to have a small microprocessor implanted in their chest. The microprocessor is going to calculate your cumulative remaining lifetime value. Now, if we sat some social scientists down, we could come to a conclusion as to what that might be. Do you play the violin? Do you have a criminal record? How many years do you have to live? How many dependents do you have? So we calculate that. You get into the car. It's running the algorithm. The car scans your chip. The car scans your chip, and it scans the chip of your passengers. So it knows the value of the people in the car. Sees the woman on the side when this emergency situation happens. Scans her chips. And so it's the one with the lowest cumulative remaining lifetime value. So that's a great societal solution, and I expect to get a commission from whoever develops this into a Nobel Prize winning idea. So obviously this is it's facetious, a little tongue-in-cheek, because nobody is going to allow a microprocessor to be planted in your chest. But this is the dilemma that you all face. The dilemma is that you now have these changing social mores where you have many decisions that were ethical decisions made by each of us in the society into your day-to-day activities. So it's an interesting thing for you to think about. So communications and the changing nature of ethics are the two things that I think are the most dramatic changes that are going to take place in the society. So I'd like to finish just with a quick note on views of my own career and what I saw in my career and what I saw in other people's careers and the impact on success. And as a result of that, I've come to the conclusion that there are really three keys to success. Those keys to success are technical competency, attitude, and networking. So as you move out into society, you're going to be working for a large corporation, doing something entrepreneurial. There's a lot of different things you could do. So what I've seen in every successful person is the following three characteristics. First is technical competency. You have to find something that you do better than anyone else around you. It can't be something that you're just sort of, okay, I'm as good as everyone else. You have to find a way to stand out. So if there isn't something that you're dramatically better at than everyone else around you, you will never be seen, and you will end up not getting to what potentially your ultimate ambitions are. So you have to find that element of technical competency. There's an old poker adage that says if you sit down around a table to play poker, if you don't know who the pigeon is, it's you. So what you have to consider is this self-identification of knowing what you're good at. The second is attitude. With attitude, if you're not the person that everybody wants to be with, the friendly person, the person's always on time, all of those aspects of it, you're ending up putting yourself in a position where you're not going to be recognized as a person who is going to be the successful person in the organization. And finally, the last element of it is networking. No matter what you do, you need to continue to expand your network and be in contact with as many people as you can, because it opens up opportunities and allows you to get people to understand what you can do. Julio mentioned connectivity, and I know in my own career, and I know that people I know who are successful, they spend a lot of time going to meetings, meeting people, communicating, and particularly with today's level of communication capability, it's an easier thing to do. So this is an exciting time for all of you, and I congratulate you on your degrees and wish you the best success in the future. Thank you.
Thank you, Dennis. We will now continue the ceremony with the hooding of our PhD candidates. The Northwestern hood that will be bestowed on each of you is comprised of a blue velvet ribbon that represents a Doctor of Philosophy in Engineering, and the purple and gold silk, which are the colors of Northwestern. The doctoral advisor will place the hood over the shoulders and offer congratulations to the PhD graduate. Senior Associate Dean Ajit Tamhani will read the student name and the doctoral advisor as each PhD graduate is hooded.
Thank you very much, Dean Otino. Good morning. Here is how the PhD hooding process will work at today's ceremony. I will read each student's name, and the graduate will then proceed across the stage to receive the hood from his or her advisor. Each candidate's name will be displayed on the screen as they cross the stage. Some candidates also have images on their slides from their research. We have a professional photographer at the end of the stage who will take a picture of each graduate after they have received their hood. We will begin with the Department of Biomedical Engineering. Adenike Adekumbi Adewui. Advisor Todd Koiken and Levi Hargrove. John Spanius. Advisors Levi Hargrove and Eric Perot. Next, we have a PhD graduate from the Department of Chemical and Biological Engineering, Teresa DeLuca. Advisor, William M. Miller. Next, we have a graduate from the Department of Civil and Environmental Engineering, Zhen Hao Shi. Advisors, Richard J. Fino and Giuseppe Buscarnera. Next, we have PhD graduate from the Department of Electrical Engineering and Computer Science, Zena Atrash Leong. Advisor, Michael Horn. Jaeun Liu. Advisor, Matthew Grayson. Yang Teng. Advisor, Matthew Grayson. Matthew Woods. Advisor, Agalas K. Katsagalas. Finally, we have a PhD graduate from the Department of Material Science and Engineering, Justin Gary Railsback. Advisor, Scott A. Barnett. This concludes hooding of our PhD candidates finishing this December. Nearly 100 additional PhDs will be awarded in June. We will continue our ceremony by recognizing our master's candidates now. We will begin with graduates from the Master of Science in Analytics program. Kapil Bhatt. Edward Stephen Binkley. Daniel Lee Breitbach. Valentino Constantino. Kelsey DeMott. Alisa Diane Everding. Min Yan Fan. Theodore Feder. Ashley Felber. Chet Gray. James Green. Yeah, Eli Hani Harik. Ke Wang. Men Shan Jin. Lee Can. Priyanka Kancharalila. Yang Jen Kung. Van Bin Lee. Yi Li Lee. Patty Lu. Yan Lubashawski. Eric Lundquist. Macon McLean. Melissa McNeil. Balmurli Natarajan. Terence Newman. Ling Xiao O. Kate Elise Overstreet. Pranav S. Rao. Vijay Ravichandran. Barthélemy Saugrain. Elena Murray Smith. Apurva Subramaniam. Brian Trent. Katie Wu. Jade Yang. Luai Young. Next, we have the Master of Science graduate from the Engineering Design and Innovation, Catherine M. Adamski. Partha Bhatt. Raymond Chen. Jonathan Robert Crow. Amelia Fish. Madeline Page Klichowski. Aubrey Eisling Kraft. Claire Kathleen McCloskey. Alan Perlman. Karen Juana Adriana Maria Schmidt. Delphina Sitar. Georgios Skoupalas. Yilin Wong. Next, we have the Department of Electrical Engineering and Computer Science, Wai-Kang Zhang. Sishan Yu. Peng Yuan. Yuanwei Zhang. Now we have a Master of Science graduate from Biomedical Engineering, Nilofer Wafi. Now we have a graduate from the program of Master of Science in Biotechnology, Connor Feeney. Megan Renee Spees. So we have a Master of Science graduate from the Department of Chemical and Biological Engineering, Tiffany Kwakwa. So now we start with the Department of Civil and Environmental Engineering, Z10A. Shou Yi Ding. Hernando Nettle Ginting. Xiang Li. Yu Lin Lee. Yu Hao Liu. Nathan Van Winkle. Tatiana Vargas Londano. Hei Yi Wang. Ying Hao Wen. Xin Rui Wu. Yitian Zhang. Shuai Zhang. Shonan Zhou. Now we start with Department of Electrical Engineering and Computer Science, Lun Rong Chen. Yi Min Chen. Zi Lin Chen. Wei Han Chu. Angel German Espinosa Coraza. Yi Fi Gay. Yuan Hui Yang. Yan Gong. Jing Ming Guo. Tian He. Hai Liang Hu. Shiki Hu. Wei Feng Wang. Tian Qi Gao. Xiang Yu Ji. Lin Jiang. Wladislaw Karyukin. Yamin Li. Junji Lee. Gang Lee. King Lin Lee. Rui Liao. Pai Ying Liu. Nian Zhu Li. Unan Ma. Dong Ming Mu. Dai Wen U. Ye Yi Peng. Hai Kun Liu. Di Sheng Liu. Sida Liu. Jun Han Liu. Yan Liu. Jai Ju Ni. Sandeep Raju Prabhakar. Yi Yi Ren. Zhe Bin Shen. Shu Teng. Aishwarya Vaikuntham. Qian Wang. K Wang. Min He Wang. Meng Chao Wang. Li Tong Wang. P. U. Wang. Yun Tao Wang. Yi Cheng Wang. Yu Zhu Wang. Zi Chen Wang. Chen Shan Wen. Shi Wu. Yang Wu. Anki Singh. Yanan Shu. Gao Shu. Ye Shu. Zhang Yan. Rong Hu. Bai Yu Yang. Wang Zhuang Zhou. Tian Yu Zhao. Jin Yu Zhang. Han Jun Zhang. Zi Jun Zhang. Wen Ji Zhang. Chen Hui Zhou. Lei Zhou. Shengji Zhu. Fei Zhao. Xiping Zhao. So now Senior Associate Dean Rich Lupto will continue to introduce the Master of Science graduates.
We now move to the Master of Engineering Management, Jeremy Ballance. Rodrigo Donoso Arias. Cheket R. Mehta. Moeen Mujib. Rodrigo Oviedo. Carlos A. Villamizar. We now move to the Department of Engineering, Science, and Applied Mathematics. Hao Li. Boying Zhu. We now move to the Master of Executive Management for Design and Construction, Mark Tarulli. Moving now to the Department of Materials Science and Engineering, Quan Hua Chiu. Scott Sidney Dinasky. Ryan R. Culpins. Keiting Lee. Justin Lim. Menghom Wang. Wei Young. Chu Zhen. Jiru Zhang. Kevin Zhao. Dijeng Zhao. We now move to the Department of Mechanical Engineering. Shant Alexanian. Gail Curry. Muyang Deng. Rishikesh Gotar. Charles Edward Hoffert. Jianyu Huang. Nikacharn Luprungsarat. Yuawei Liu. Meng Lu. Aditya Ramkumar. Yuling Shen. Angela Young. Jinbing Ying. We now move to the Master of Project Management, Zinakar Ahmed. Christos Alexakos. Fadel Nassar Akuwetim. Sing Shai. Ying Du. Jihi He. Ziad Kashmar. Simran Kurana. Bojay Lee. Yating Lee. Chen Liang. Chen Lin. Tianyang Liu. Pacharon Sikajorn. Xiaolong Tang. Chenshin Wang. Haiyu Wang. Jinsheng Wang. Yaheng Wang. Jolun Wang. Pei Wen Wu. Renli Shu. Zitong Zhu. Yushin Zhou. Yuting Zhang. We now move to the Master of Science in Robotics, Sofia Akmamateya. Ban Bai. Tane Chowdhury. Nathan Corwin. Matthew T. Cruz. Timothy Herman. Alan Hong. Minghua Jiang. Yunshu Liu. Abhishek Patel. Mikhail Todas. This completes the conferral of master's degrees. Please congratulate all of the graduates with a well-deserved round of applause. I now welcome Dean Otino back to the podium.
Thank you. So let me once again add my congratulations to all our graduates. Today marks an important day in your careers and in your life. Your degree is a significant accomplishment, and I hope that the skills that you have learned here have prepared you for a lifetime of impact. Although your careers may take you far away from campus, we hope to see and hear from you on a frequent basis. As alumni, you are the source of our value. We are only as good as the people that we produce. Today, we bestow value on you, but from now on, you will bring value to us by what you do with your careers. I'm eager to see what you can accomplish. Congratulations to all of you again. Now, I ask you that you remain in your place until the faculty and graduates recess. Will the graduates please stand as the procession begins?
you.